perché dà fastidio. I am full professor Cervellieri and of the Department of Information Engineering of Polytechnic University of Mark of Italy, and this research article is named A Critical Review of Lithium Battery Cyclic Process from a Safety Testing Perspective. Lithium batteries have become increasingly popular due to a growing demand for user lithium batteries, and distinct from other batteries by very high volumetric energy density, high density, and low maintenance characteristics. The lithium battery package uses a power reference and high precision battery prototype necessary to estimate factors such as battery state of charge, battery of health, and capacity. The BMS battery modeling system envisions calculating the state of charge analysis is critical to predict the proper functioning of electric vehicles. The study of the relationship between the intrinsic parameters of the batteries, particular values of the incremental capacity of voltage as allowed, as obtained and give the assessment of a state of charge of the cells of lithium batteries. In this article from ion batteries, important considerations have emerged regarding about battery performance of the datasets of the models that calculate in the propagative degradation of the battery, define important consequences for the future improvement of the circuit innovation method based on the aforementioned technology. In recent years, lithium-ion batteries have increasing developed in the market due to the enormous demand of the user. In the automotive sector, we have seen the enormous development due to the benefit of the product. BMS is used to monitor battery status and avoid hazards such as fire and battery explosion. The calculation state of charge fins countless applications of a specific field that are addressed by means of a series of models, as described in the scientific literature. BMS cannot limit itself to potentially useful models for applications. The methods of analysis of the state of charge and state of health are fundamental in field lithium batteries, but have a series of disadvantages that limit their use and make them prefer some based on the characteristics that distinguish them. I've used a fuzzy logic algorithm in association with an artificial intelligence model and a camera filter to predict the case of incidents and explosion caused by anomalies and chemical parameters instable, and superior to a particular value that makes instable the parameters of lithium batteries, and I have calculated with the use of a particular case of an artificial research in a precise manner to avoid so dangerous that are considered the mean responsible worldwide for problems of internal stability of batteries to the point of leading to fire explosions in 18% of cases. Running time-based electrical model cannot accurately predict either operating time or voltage response and dynamic load conditions. Despite the ability to predict battery uptime and dynamic behavior with relatively high accuracy, combined electric model has the disadvantage of not predict battery health and auto-updating parameters. To overcome this phenomenon, I decided to create an important artificial intelligence algorithm already studied in the article 5 to avoid that the results of the forecast will be less accurate as the battery degrades. For this reason, fuzzy logic can be used with the modelization of chemical properties in a first simulation with minimal data, making the necessity to describe some prerequisites of the model. In this way, the modeling has low computational burden without being dependent on the case study analyzed, without affecting the results achieved up to now, as dusted from the comparison with scientific literature 6, 7, 8. Table 1 are present an overview of the dataset available that I have studied in a precise manner precise and exactly manner, perfect manner. So to can say broad that my model is supported by scientific literature and made a new theory about lithium-ion batteries. Important to at global level. For a correct prediction of state-adjusted health, sources of error in the methodology and model are defined in 5 fundamental fields in both current and voltage sensors, 0 sensing noise, incorrect temp, errors in modeling or model due to measurement inaccuracy or lack of accuracy, errors in the initial parameters assumed, errors in the optimization process, a combination of above causes. In conclusion, lithium-ion batteries are increasingly developing in international market. In this article, a review of lithium-ion batteries dataset has been analyzed, taking into account the prominent world universities that have developed them, describing the characteristics concerning the test, the measurement instruments, test, and the type of cell analyzed. In this particular, finally analyzed in this particular case study. In recent years, numerous authors have studied in electronic sector. This particular case study is used to study the in electronic sector in this particular way with the use of artificial intelligence. Case study with the use of artificial intelligence applied to the particular case study. Case study. Thank you for your attention. I'm at your disposal in comments to answer any questions.